So welcome to my next video of complex number part 4C. In this video we are going to discuss about the important notes of arguments. Okay, let's start about that. Number 1, argument of a complex number zero is not defined. That is, 0 is represented by 0 plus I into 0, and we know that the argument of a complex number is theta tan inverse b by a. If if we denote this is by a and this is by b, then the denominator becomes 0. So something by 0 is undefined. Okay, so this is not valid. Okay, next. Now if z1 z2, the complex number z1 equals to z2. Okay, if z1 equals to z2, if and only if mod z1 is equal to mod z2 and argument of z1 equals to argument of z2. Okay, also there are one remaining point which are going to discuss about, that if argument of z equals to pi by 2 or minus pi by 2, then z is purely imaginary. Z is imaginary. Okay, and if argument of z equals to 0 or pi, then z is real. Okay, got it. Now we are discussing about the properties of the argument. Properties of argument. Okay, number 1, argument of z1 z2 equals to argument of z1 plus argument of z2 plus 2k pi, where k is 0 or minus 1. Okay, number 2, argument of z1 by z2, that is argument of z1 minus argument of z2 plus 2k pi, where same k is 0 or 1 or minus 1. And there is one more point I have forgotten about, that 1 or minus 1. Okay, where k is 0, 1 or minus 1. Okay, number 3, argument of z1 divided by z2 bar, that is 2 twice of argument z plus 2k pi. Okay, this is not z1 z2 because this is the complex number represented by z and it is the conjugate complex number. Okay, the argument of z by z bar equals to twice of argument of z plus 2k pi, where k is 0, 1 or minus 1. Okay, Number 4, argument of z to the power n is equals to n times of argument z plus 2k pi, where k is 0 or -1. Number 5, if argument of z1 by z2 equals to theta, then argument of z1 by z2 equals to 2k pi minus theta, where k belongs to I. Okay. Now argument of z conjugate of z is equals to minus of argument of z. Okay. 7, if argument of z is 0, which implies that z is real. Okay, so one point must be noted that we have discussed one properties 1, 2, 3, 4, where the left hand side is must be lies the value of k. We have to adjust in such a way that this must be lie in minus pi to pi in this interval. Okay, so note that proper value of k must be chosen in such a way that RHS of 1, 2, 3, 4 lies in minus pi to pi. Okay, so that's the end from today. In the next video we are discussing about the properties of modulus. Okay, thank you.